Today we will be talking about questions from the AP Chemistry exam, including 1 free response question and 3 multiple choice questions. The free response question will be question 5 from the 2014 test. Some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of fluorine atoms that will bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. Based on the student's hypothesis, what should be the formula of the compound that forms between chlorine and fluorine? To answer this question, we must first understand the hypothesis that the student posed. An example of the student's hypothesis would be OF2. Since oxygen has 6 valence electrons, that would mean 8 minus 6 equals 2, meaning that you would need 2 fluorine atoms and 1 oxygen atom, which would create the compound OF2, which you can see is correct in the table above. To discover what the formula of the compound that forms between chlorine and fluorine is, we must first figure out how many valence electrons chlorine has. Since chlorine is in the halogens group, we know that chlorine has 7 valence electrons. Following the hypothesis, 8 minus 7 equals 1, meaning that you would need 1 fluorine for every chlorine. This would make the compound ClF. In an attempt to verify the hypothesis, the student researches the fluoride compound of the other halogens and finds the formula ClF3. In the box below, draw a complete Lewis electron dot diagram for a molecule of ClF3. To draw the Lewis dot structure of ClF3, we know we must first put the Cl atom in the center. We then connect the fluorines to the Cl with single bonds. We then fill in the octets of the fluorines. Once we fill in the octets of the fluorines, we still have 2 pairs of electrons. We then put those over the chlorine. Elements with valence electrons in the 3p shell and below have the ability to expand their octets by using their d shell. This is what we observe when we draw ClF3. 2 possible geometric shapes for the ClF3 molecule are trigonal planar and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that ClF3 molecule has a dipole moment? Justify your answer in terms of bond polarity and molecular structure. In terms of molecular structure, the electron domain of molecules for T-shaped is AX5. In terms of ClF3, the molecular geometry would be AX3E2. The electron domain of molecules for trigonal planar is AX3, while the molecular geometry is AX3 as well. Based on the Lewis structure we drew in part B, ClF3 is T-shaped because it has 2 lone pairs. In terms of bond polarity, trigonal planar molecules are symmetrical. If all the bonded atoms are identical, then they will have their net dipoles cancel each other out due to the symmetry. This is not true for molecules with lone pairs, as those disrupt the symmetry, as is the case with T-shape, AX3E2. Molecules without symmetry have dipole moments. Therefore, the student's research about the molecule having a dipole moment is consistent with T-shaped. In an attempt to resolve the existence of the ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and fluorine and assembles the following list. Based on the concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. The number of unique compounds that form is equal to n-1, where n represents the period number. The formula for the compounds that form are always 1 halogen to x fluorines, where x equals 2w minus 1 for all positive whole numbers. W is less than n-1. For the multiple choice questions, we are referring to an AP exam from 1999, questions 5 through 8. A method to solve these is to count the number of electrons and then relate them to the protons to discover what element it is. From these options, which represents an atom that is chemically unreactive? Option D is an element that is chemically unreactive due to it being a noble gas. We know it is a noble gas because if you discovered what element it was beforehand, you would know that it was neon, and if not, you would see that all the orbitals were full. Number 6, represent an atom in an excited state. An atom in its excited state would be option A, which is hydrogen. We know it is excited because the electron is in the 2s orbital instead of the 1s orbital because it absorbed energy and is now in an unstable excited state. Number 7, represent an atom that has 4 valence electrons. We know option C has 4 valence electrons due to its outer shell being the 2s and 2p shell, and counting the electrons in there, there are 4 valence electrons. We also know there are 4 valence electrons because if we had figured out the element earlier, we knew that it was carbon, which has 4 valence electrons. Number 8, represent an atom of a transition metal. Option E is an atom of a transition metal. We know this because there is a 3d orbital present. We also know this because earlier, if we had figured out what the element was, we would see it was iron.